Alright, good afternoon. Sorry about that. This is my integrated 1 honors lesson for section 20.2 in the book. I wrote the goals on the board, but I guess before I get started, I should again say that I hope everyone's doing well. I'm getting a lot of you guys turning in the assignment, with the exception of 3 on the assignment that was due yesterday. I want to make sure I'm getting all of you guys to do the work. Again, this is a very interesting time, and if you're turning in all the work, you really are putting yourself in a position to say, I should pass this class, so please, again, make sure you're doing everything that I assigned. Back to the goals. We are going to talk about something called ASA triangle congruence criteria, and we're also going to have an introduction into 2-column proofs. So let's go ahead and just jump right into the ASA. It's actually a simpler concept than what we did yesterday. So let me just remind you a couple things about what we did yesterday. We had a pretty strict criteria to argue that triangles were congruent. All parts had to be the same, and they all had to be in the same position. So we literally had to show that we had 3 congruent pairs of sides, 3 congruent pairs of angles, and these guys all had to be in the same position on the triangles. They had to be corresponding. And once we established that we had this happening, we could then say that because the identical parts were in the same positions, that meant the entire shapes themselves must be congruent. So it was actually quite a lot of work to argue that triangles are congruent, whereas today what we're going to see is a simpler way to show that triangles are congruent. And the ASA actually stands for angle side angle triangle congruence. So let me just kind of talk about why it works, and then we'll start talking about what you're looking for, and then I'll move on to our second goal. And that's going to be an introduction to 2-column proofs. Okay. So I hid my marker from myself. Oh, there it is. And let me introduce you to the angle side angle triangle, congruent triangle idea. So angle side angle side angle triangle congruence. Okay. So I think it's easier to see visually. And what we're doing is we're actually looking for congruence patterns in the triangle. So again, we don't need all 3 sides and all 3 angles. We actually just need an angle, a side, and an angle. So if I have an angle and a side and an angle, if I have this congruence pattern in 2 triangles, I can then conclude that the triangles themselves must be congruent. So again, you can see that it's a much simpler congruence pattern that they're working with. I do want to point something out. Notice that the congruent side is between the congruent angles. It has to be. Alright? So because I have this congruence pattern, what I can say now is that these 2 triangles themselves must be identical. This is good enough. This is all I need to conclude that my triangles are congruent. So having this means that we get congruent triangles. And remember, when you get congruent triangles, what that means is that the congruent triangles means that all the corresponding parts are equal. So if let's say you were trying to figure out, that length, you actually can now set this length equal to that length, because we know that the triangles must be congruent because of the angle side angle triangle congruence. Now it's a little hard for me to explain why this works. If we were still in class and we had our compasses, I would actually have you guys copy a triangle by first copying an angle, and then we copy a side, and then we copy another angle, and we'd actually see that we've actually built the exact same triangle. And I guess the idea would be that, you know, let's say that we have a triangle that's, I don't know, 34 degrees, and we'll say that this is 10 units, and we'll say that this is 41 degrees. So if you were to make an angle and you built it in such a way that it was 34 degrees, and then you were to get a length that you guaranteed was a length of 10 from here to here, and then you were to build another angle from here, and you built it in such a way, or copied it in such a way that it was 41 degrees, you've actually constructed identical triangles. These triangles must be the same. And this is the angle side angle pattern. This actually reminds me of, I thought it was funny when I was taking my geometry class, and I remember asking, Mr. Weeks, is there an angle side side triangle congruence? And my teacher looked at me and he said, Chris, the only angle side side in the class is you. So that's not one of the things that we're going to be working with, but angle side angle is something that we're going to be working with. So we're looking for this pattern. We want this pattern. Now I will give you a clue to some problems that you will see. Remember that we know what all three angles of the triangle add up to. So that's going to be a part of some of the questions that we're going to see. So I guess that would probably be a good thing to note. A clue: the three angles of a triangle add to 180 degrees. So we're going to see somewhere in your homework, that's a good idea, we're going to see that, we're going to see this idea come to life. So this is what we want. We want this. Okay. Now, I'm going to try my best to talk about proofs. Let me first give you guys, proofs aren't easy. They're kind of hard. It's going to take some practice, and that's okay. I mean, they're learning something. You're learning it online. I'm not going to get any questions or direct feedback. So this is going to be a difficult lesson to convey, but I'd like to try and just discuss the structure of the two-column proof and have you guys hopefully have some success. I'm positive I'm going to get questions on this, which is totally expected and acceptable, and it's acceptable to ask questions on anything, actually. So let me talk about the structure of the two-column proof. So I've talked about this. I'll talk about this. So when I say a two-column proof, I'm on to my second goal now. When I talk about a two-column proof, we're going to actually create two columns. And in the first column is a claim. We're going to call this our statement. And every claim that you make, you have to justify it over here. And this is going to be called our reason. Okay. Now, right now, the whole goal for these two-column proofs is you're trying to argue that you have angle, side angle, triangle congruence. You want to argue through this side that you have, that you've made this argument. This side you're justifying it. So I'm having a little bit of a hard time coming up with a problem off the top of my head. But actually, with regards to this, I don't want to do the, as I actually think about this, I don't want to do too many of these for you, because if I mean, there's really only a limited number of problems, right? So let me first of all talk a little bit about the structure. So in this 2-column proof, they're gonna give you a statement. There's a given, and it's gonna be something like this, and then they're gonna ask you to prove. Right. So right now, what we're going to try to prove is we're going to try and prove that our triangles are congruent. That's what we're going to work towards, right? And let me make something very clear. The very first step of any problem, of any 2-column proofs, is you're going to tell me what was given to you. That's always going to be your first statement. And the reason that you can say that first statement is it's your starting point. It was given to you, right? And somehow, some way, this and your picture, there'll be a picture with this as well. There's clues on this so that you're going to be able to accomplish an angle-side angle congruences. So maybe you need to argue that you have congruent angles, right? And maybe in your given statement, it allows you to get to the point where the next thing you can say is, hey, I got congruent angles. And you make a statement about that, and then you have to tell me why you can say that. But let's say this statement you made, that allows you to get an angle, right? And so I'll draw a picture, just for, let's say that this is our picture. And let's say that, hey, you were able to argue that you had some angles that were congruent. Right? Okay, so now I got an angle. I got that happening. And let's say that, there was also something in the first statement that you could make the claim that, hey, I got another set of congruent angles, and you argued why, and here you have your second angle. So I would actually recommend writing angle side angle off to the side and crossing out the letters as you got through each of these claims, right? Now I need to make a claim about the side, and I'm actually going to do a specific example. If I was to say that this side here had endpoints A and B, I could actually say the following statement. I could say that the statement that AB is congruent to side AB, and the reason why that I can say this is that there's this idea, this is not the second, there's this idea in arguments about this property called the reflexive property. And the reflexive property literally means that something is the same as itself. And so now if I mark that and realize that I have a side, it doesn't matter that these letters aren't in the order of this. What matters is the pattern of congruence in the picture. The way that you argue it, you could have made this before. You talked about the angles, but I've accomplished all three congruences, and they were all in the right place where I needed them to be. And so the very next thing that I could do is I could make the statement that we have congruent triangles, and the reason why we would have congruent triangles is because of the angle side angle triangle congruence. Now, maybe you need to go a little bit farther, because once you have the congruent triangles, you know that their corresponding parts are also congruent. So maybe you have to go a little bit farther with this argument. Now, this probably seems very vague. So maybe tomorrow I will do a proof from the homework in this. I think the first one's first one in the book, if I remember correctly, it's a fill in the blank. And again, for me, like, you know, this isn't the only thing that we can argue. We want to argue that we have a congruent set of congruent angles, the side, and then the set of congruent angles. We're ultimately looking for this type of congruence pattern. Now I'm going to draw these oriented in a different way, but again, we want this type of congruence pattern. And, you know, as you go through these proofs, just keep in mind, can you cross out one of these letters in this? And once you've crossed them out, and you've gotten to the point that you can get to the conclusion that the triangles are congruent. So I left that as kind of a blank statement, because it could be you were asked to show that the triangles are congruent. Or it could be that you're going to be asked that you needed to show that these segments are the same. So if you're asked to show that these segments are the same, the structure of the proof is, well, first of all, I'm going to argue that my shapes as a whole, those are identical. And once I've argued that they're identical, then I can then say, well, since they're identical, the parts must also be identical, and then we can make another step in that conclusion. It's also very helpful when you do two-column proofs. Add to the picture, draw on the picture. Geometry is a very visual mathematics, and if you're not marking things and keeping track of what you've discovered, you're going to have a harder time creating this argument. So again, this takes some practice, and I expect you guys to struggle. It's not an easy thing. I'll tell you that right now. It's not going to be something that it's a new idea. This is the first time you've seen a two-column proof. And again, give it a shot. Give it a shot. Try the best, or try your best. That's all I can ask out of you. And hopefully, you know, we can kind of work our way through this. I do expect to get questions on this, and that's all right. You know, this is we're learning, and it's all right to have questions. All right, so I'm going to stop there. I'm going to post this lesson. Again, I hope everyone's doing well. Hang in there. Make sure we're doing everything that's assigned to us, you know, so we can say, hey, I deserve to pass. You know, and let's make sure that, you know, if you have any questions, let me know. And I do want to also say that some of you are having some problems submitting assignments. Don't give up on submitting. If you're having a problem, reach out to me. Don't get frustrated. There's no need to get frustrated with the technology. Just say, hey, I'm having problems. What should I do? I'll get back to you as soon as possible. Don't stress yourself out. All right, don't let that stress you out. All right, so again, I hope everyone's doing well. I will post the next lesson tomorrow. Have a good day.